Hello everyone, I'm Siddharth, and today we are going to see about text processing and natural language processing. And after we will be discussing the application of text processing that is in the mind map generator. So our project title is mind map generator using natural language processing. In that we are going to use text processing concepts using NLP. So now let us get started. So in this video, we are going to discuss about various types and techniques of text processing. So I'm Siddharth Thakur. This video is regarding my course CSC 3022, that is Natural Language Processing. It is a review one, which is a video submission. And the title of my project is Mind Map Generator using NLP. So here I will be attaching a video link also. And then the concept, let us talk about the concept which we are going to see today. So the concepts are introduction to text processing, introduction to natural language processing. Then we'll be seeing about the concepts included in text processing for natural language processing. So this includes seven important concepts that are sentence tokenization, word tokenization, text lemmatization and stemming, stop words, regex, that is regular expression, bag of words, and TF-IDF. So all these concepts we are going to see in detail. And at the end, we'll be discussing about the text processing, which what is its application with respect to our project MindMap generator. So let us get started. So let us see about the introduction to text processing. So what is text processing or text mining? So it is an automated process which uses natural language processing to extract valuable insights from unstructured text. So whenever we are having some unstructured text or anything like which is unstructured in unstructured manner, so in order to automate that using natural language processing, we use text mining. Okay. So by transforming the data into information, machines can understand. Text mining automates classifying text by sentiment, topic, and intent. So by the means of converting the data into some information, we can classify it in terms of sentiment, topic, and intent. So this text mining will help us or businesses to analyze complex and large set of data in simple, fast, and effective way. At the same time, companies are taking advantage of this powerful tool to reduce some of the manual and repetitive tasks, saving their team's precious time and allowing customer support agents to focus on what they do best. So a text mining algorithm. So for text processing, there are various algorithms. So this algorithm help us in identifying the popular topics. So a text processing algorithm will help us to identify popular topics that arise in customer comments and the way that people feel in them. And these are classified as positive, negative, or neutral comments. So let us see what is NLP. So NLP stands for natural language processing. It is a field or subfield of computer science and artificial intelligence that is concerned with interactions between computers and human languages. So NLP is helpful to communicate users with the communication devices. Okay, it is used to apply machine learning algorithms to text and speech. So, for example, we can use NLP to create systems like speech recognition, document summarization, machine translation, spam detection, entity recognition, question answering, autocomplete, predictive typing. This all are the many applications of the NLP nowadays. So, some of the examples of NLP are Cortana, which is used in Windows widely for speech recognition, Series in iOS, and also one of the application is Gmail. So Gmail also has a spam detection. So that spam detection is already done through the NLP mechanism, already existing algorithms for Gmail, which help in detecting the spam and filtering out those emails. So let us talk about the main topic which we are going to discuss now. That is the text processing for natural language processing. So Natural Language Toolkit, NLTK. is a platform which is helpful for building Python programs with that work with human language data. So this NLTK will help in building the interfaces for corpora and lexical sources. It contains a suite of test processing libraries for classification, tokenization, stemming, tagging, parsing, and semantic reasoning. So best of all, what is the best part about it is NLTK, the natural language toolkit, is completely free, sorry, open source, community driven. So now let us discuss about the first application of text processing, that is sentence tokenization. So sentence tokenization is the problem of dividing a string of written languages into component sentences. So sentence tokenization means when we are having a problem or a given series of sentences or a paragraph in short, it does the work of splitting the sentences or with respect to the punctuation mark. So this is suppose a sentence given to us. We have to apply NLTK over it. So we'll use the syntax NLTK dot sentence tokenize. So this function will automatically tokenize this complete upper paragraph to give us this paragraph, which has splitted the paragraph into three different parts. So this has tokenized the sentence. So now the word tokenization. So this is quite similar to the sentence tokenization only. So in this, what happens is previously we splitted the sentences, but now the words will be tokenized. So here we have an example. So this is how the word tokenization takes place. Each of the word is represented individually. Now text lemmatization. So for grammatical reasons, documents can contain different form of words such as drive, drives, and driving. So some words which have same meaning but are often used in different forms. So such type of words are called as lemma words. So that we need to remove. So examples are am, are. So this all are equal dog, dogs, dogs. This all are equivalent to dog. So this lemmatization will summarize, will take different forms of word and convert it to a single form. So let us see some example. So what is the lemma for better? It's good because they mean the same. For play, it's playing. See? Now the meeting, it has the lemma to be as meet. So see, the stemmer word is see, its lemma will be see. The stemmer is throw, the lemmatizer word will be drive. Let us see the next, that is stop words. So as the name says, stopping the words. So what does it stop? The words which add a lot of noise. A lot of noise means, so this stop words will filter out all the repetitive words or the unwanted irrelevant words like and, a, which are continuously used in a sentence, which carries no sense. Okay. So let us see here the examples of it. So see, output, I, me, myself, we, are. So these all are the least prioritized words. So output will be backgammon, one oldest known board games. So among all these words, which all are the important words are characterized over here. Now, what is regex? Regex means regular expression. So regular expression will do what all things? It will give you when you match it with when you match a particular pattern with a paragraph or a sentence, it will give you the matching words. Okay. Sorry. So a regular expression has a certain syntaxes. So this dot represents any character except the new line. Slash W represents match a particular word. Slash D represents matching a particular digit. Slash S represents match the white spaces. A capital W match not word, capital D match not digit. Slash X S match not white space. And then in bracket, if you write small abc, that will match any ABC. If you put a hyphen and then you write not ABC, it will not match ABC. If you give a hyphen and you write A to G, it will match a character which is in between A to G. So this is how we do regular expressions, which will give us the same development of the same pattern developed in the string. This is the example. This is an example of a text given to us. You can see. So what is there? So now the next is bag of words. So bag of words means lots of words. So machine learning algorithms cannot work with raw text directly. We need to convert the raw text into vectors of numbers. This is called feature extraction. So in machine learning algorithms, we cannot convert the text directly. We need to put them into vectors of numbers. So bag of words will help us in simple feature extraction technique, which is used when we work with text. It describes the occurrence of each word in the document. So we need to do, there are several steps to do it. So first we need to design a vocabulary of known words and choose a measure of the presence of other words. And the second step is choose a measure of presence of words. So any information about the order or structure of word is discarded. That's why it is called as bag of. So example is given. So first what we have to do is first we'll load the data. So for loading the data, this is a tool which you can use, node text icon. So let's say that this is our data and we want to load it in an array. So our data is a sentence and this is how we have loaded into an array. Then we need to design the vocabulary. So for this book content diary, Google is a tool which we can use. Here is a sentence. Let's get all the unique words from the four loaded sentences, ignoring the case, punctuation, and verb. So now we'll load the words in the vocabulary and then we'll count vectorize class will be importing from SQL library and then we will be designing our own vocabulary. Now we'll create a document vectors. So for document vectors, we need binary icons. Okay, so for binary icons, we'll give some words of classes for 0 and 1 in terms of 0 and 1. So here, awesome has been given 0. So for a particular sentence, we are giving it as classes. So if the word awesome, funny, hate, if this are occurring, it will give us 1. If this are not occurring, it will give 0. And 0 and 2, 3 and are the sentences. Okay, 0 is sentence 1 is sentence 2, these are the sentences. And if these words are arriving in that sentence, it is given 1, and if it is not arriving, it is given 0. So here are sentence. Now we can see how bag of works. So this is the output of how bag of words work. Okay, so next we'll see. So this is some of the drawbacks and other information about bag of words diagrams. So now we'll see the seventh or the last topic, that is TF-IDF. So in TF-IDF, one of the problems with scoring word frequencies that most frequent word in document start with highest speed. So that most times does not mean that it is the information clear. So one of the approach to fix that problem is to penalize words across frequent documents. So this process is called as TF-IDF. So the full form is frequency inverse document frequency. It is a statistical measure which is used to evaluate the importance of a word to a document in the collection of or corpus. So the TF-IDF scoring value increases potentially to the number of times a word appears in a document, but it is offset by the number of documents in the corpus that contains the word. Let's see so now we'll see the formula to calculate TF-IDF. So Wx of y is TFXY into log of n upon dx. So where TF is the frequency of X word in sentence Y, DFX is the number of documents containing X, total number of documents is N. So there is a link for the formula where we have taken it from. Now TF, that is a term frequency, is given as the number of terms, number of times term appears in a document divided by total number of items in a document. So this will give us the term frequency. Now, if we have to find an inverse term frequency, that is ITF, the formula is log of total number of documents divided by the number of documents with the term in it. So inverse document frequency formula is this. So finally, we can use the previous formula to calculate TF and IDF. So TF IDF is calculated to TF of term into IDF of term. So TF of term, previously we got this formula. So by using this formula, we can calculate TF. And then IDF is calculated by this formula. And when we multiply this both, we get TF IDF. So this is the formula for TF IDF. So the application is going in here. TF IDF vectorizer class is imported from sklearn library to calculate a particular data set. So like previously we have used for the sentence, on the same we have applied this TF IDF also. So now the main thing which we are going to use, how we are going to use the text processing for mind map generation in a project. So the final result of the mind mapping system of ours, which we are going to design, is a 4 mind map, which is inspired by graphs that will be generated with respect to the text section. So the graph for a section, which we have seen in the previous figures, like the figure I will attach in the appendixes part. So that will provide the best visual representation of all the sections analyzed. So this was mainly due to the organization of the section 1 text because evenly split its content into 4 subsections. Because now by using the BERT text summarizer, this is the tool for summarizing the text. Each paragraph does a pretty accurate job at representing the major points of its corresponding text. Now, if for example, if you see a sentence rocking around the clock, now does a great job expanding on almost every important concept mentioned in the sections. So there was some minor and major concerns that the summarizer has. However, because of the model had a set minimum for the minimum number of sentences, the BERT text summarizer further limited because it is an extractive system, which means it does not rephrase the sentence into text. It will only pull the ones it is considered significant. The dependency parcel performed pretty well in all the graphs. And accurately, it will split the key concepts from their respective attribute in most of the classes. This is demonstrated in the figure 9, which will be again given in the appendix, where the subject of each sentence is identified as a key. So there are a few mistakes. However, we found that there are a few mistakes that some words were excluded from the key concept that were either incorrectly added to the attribute or left off. As an example, this can be found in figure 8, which was under slaves and Indians branch where the second concept Washington owner. So this is a big center. Washington owner of slaves during revolution is missing from the more than 2. It changes the context. So here was a mistake done by the mind map generator. So basically, the text summarization which we are using is done by the text corpus. Okay. So for text corpus, we are using the text summarization techniques. Then the summarized text will be selecting the key topics to create a mind map. So text summarization will be very easily available for us for any data which we want to process into it. So mind map will be specifically included in the library function of the sklearn packages, and by using that library function and the packages, we can easily change the width, depth, and control all the other dependencies of the mind map which we want to generate. So let us now summarize what we have learned until now in this video. So we have learned the basic concepts for NLP, which are used for text processing. We have learned NLP, how it is used in machine learning algorithms to convert text to speech. Then we learn about NLTK, that is Natural Language Toolkit, which is a platform for building Python programs to work with human data. Then we learn about the sentence tokenization, that is process of dividing a string into language. Then we learn about the word tokenization, that will be dividing the words from sentence into different parts. After that, we saw the goal of stemming and lemmaization, how they reduce the inflectional form and sometimes derivational related forms of word Then we learn about the stop words, sorry, a review expression. That is a sequence of characters that define a search pattern. Then we saw the bag of words model, which is a popular and simple feature extraction techniques. Then we, like the last, we saw TF idea, which is statistical measure used to evaluate the importance of a word to a document in a collection of corpus. So that is what for today's video. So in this video, we saw what is text summarization, text processing in machine learning and natural language processing. Also, we discussed about its application for mind map. So here we'll end this video. Hope you like this video. If you learned something from this video, do give it a like. Thank you.